Welcome to this tutorial on NumPy's geomspace function. In this video, you'll learn how to create geometrically spaced sequences, which are essential for logarithmic operations, scientific computing, and data visualization. Let's dive in and master this powerful NumPy function. Geometric spacing creates a sequence where each term is obtained by multiplying the previous term by a constant ratio. For example, in the sequence 1, 2, 4, 8, 16, each number is obtained by multiplying the previous number by 2. This constant multiplier is called the geometric ratio, and it remains the same throughout the entire sequence. The basic syntax of geomspace is straightforward. It takes three main parameters: start, which is the first value in your sequence, stop, which is the last value in your sequence, and num, which specifies how many values to generate between start and stop. The default value for num is 50, but you can specify any number you need. Let's look at a simple example. We import NumPy as np, then call np.geomspace with arguments 1, 100, and 5. This generates 5 numbers starting from 1 and ending at 100, spaced geometrically. The output shows 1, 3.16, 10, 31.62, and 100. Notice how each value is approximately multiplied by 3.16 to get the next value. Understanding the mathematics behind geomspace helps you use it effectively. The geometric ratio is calculated as the n-1th root of stop divided by start. In our example from 1 to 100 in 5 steps, we need 4 intervals, so the ratio equals the fourth root of 100 divided by 1, which is approximately 3.16. This ratio is then applied repeatedly to generate each successive value in the sequence. When working with negative values, there's an important constraint. Both start and stop must have the same sign. You can create a geometric sequence from -100 to -1, which is valid because both values are negative. However, if you try to go from -10 to +10, NumPy will raise an error because the signs are different. This is because geometric progressions require consistent sign to maintain their mathematical properties. Geomspace has many practical applications. It's commonly used for creating logarithmic scales when plotting data on log axes. In scientific research, it helps sample exponential phenomena like radioactive decay or population growth. Financial analysts use it for compound interest calculations and investment modeling. Signal processing engineers rely on it for frequency domain analysis and filter design. Understanding these use cases helps you recognize when geomspace is the right tool for your problem. Finally, let's distinguish between geomspace and logspace. Geomspace uses actual start and stop values directly. For example, geomspace from 1 to 1000 with 4 values gives you 1, 10, 100, and 1000. Logspace, on the other hand, works with powers of a base, which is 10 by default. So logspace from 0 to 3 with 4 values generates 10 to the power 0, 10 to the power 1, 10 to the power 2, and 10 to the power 3, which also gives 1, 10, 100, and 1000. While they can produce similar results, geomspace is more intuitive when you know your exact start and stop values.
If you like this video, hit that like button and don't forget to subscribe. Visit codelucky.com for more such useful content.